Hi, it's Friday, October 24th, and we're tracking Tropical Storm Melissa in the Central Caribbean this evening. The system has made quite a bit of progress in regards to its internal structure throughout the day today. And since my last video, it's gotten much more organized, and it's likely setting up for a quicker phase of intensification sometime this weekend. And so if we take a look at how the system is doing right now, we can see a much better and centered area of convection over likely the low-level center. There may still be some vertical tilt present, but compared to a couple of days ago when I made my last video, this tilt has been decreasing with time because the vertical shear has decreased with time. And so now what we're seeing in all likelihood is these two centers now vertically aligning and now a more coherent structure in the form of an eye and eyeball structure trying to be built. And it has been reported on some recon data that we're getting now this evening. And we've had a pretty fortunate day in terms of data. We've had a lot of information telling us exactly how the system has been progressing over the afternoon into the evening hours. I'll start off here with the recon flight that we had earlier this morning into early this afternoon. And what we're primarily focusing on is these orange dots showing you the system's center fix from the plane. And what you'll see initially, it's off to the left here. The end of the mission is on the right. And initially, they found a fairly weak surface circulation with the surface center of about 1,002 to 1,004 millibars. But progressively throughout the mission, the system center was drifting east-southeast, and by the end, the pressure had fallen down to 998 millibars, showing some intensification that had likely started to occur towards the end of the recon flight. Now, you may ask, is the system now just drifting towards the east? Not exactly, as we need to consider what was also going on by this time during the recon flight. If we take a look at some microwave data that happened to hit right as the recon flight was going on, we could see the low-level center here. You might be able to pick out some low-level rotation in the blue colors here. That's showing you the surface circulation here. And if you look here where all that deep convection is with all these stronger winds in the recon flight, we have some pretty strong convection going on here associated with the mid-level center. And you can see that happening with that curving in the black there. And so we still had this vertical tilt present. However, we had a pretty vigorous convection going on, and the mid-level center by this point was likely very strong, very vigorous with all of that curling convection ongoing. And so what can happen a lot of times when storms come out of a sheared environment like Melissa just had is this mid-level circulation can begin to lower pressures at the surface and create vorticity with all of this strong convection. And what that can do is, in a way, tug on, if you will, the low-level center. And so what we're likely seeing with this east-southeast dive was not really the forward motion of the storm, but that mid-level circulation tugging on the low-level center, trying to realign the vortex in this time. And we've seen further evidence that this has continued to occur throughout the day today. This is the satellite imagery again. And what you'll see now is we've got this curved band forming down to the south. And this is likely wrapping in to try and close off an ionizable structure. This is a pretty classic sign that precludes more significant intensification. And we can see it very clearly on this microwave pass. Again, here is that band forming to the south. What you'll see is that it's wrapping into the mid-level circulation like this, and it's pretty hard to find out where the low-level center is. And in all likelihood, it's somewhere underneath of the mid-level circulation. Now, from what I've seen on recon data so far, we do have a plane in there right now, this tilt has not fully fixed itself. We still have a little bit of a tilt with height, but it has fixed itself substantially from where it was yesterday. And this is likely going to continue to fix itself as, like I mentioned, the shear has decreased. And so that will likely allow that to occur. And also this curved band structure leading to very deep convection continuing in the center here will likely also aid to that vertical tilt decreasing throughout the night tonight. Now, what does it need to do to get into a phase where it's able to quickly or rapidly intensify? Well, firstly, it needs to fix that vertical tilt fully and complete this eye and eyeball structure. But also something I can note on this recon data is that you'll note that the wind is not all too concentrated and symmetric around the system center. If we take a look at the overall wind field so far on this recon flight, you can see we've got some of the stronger winds further away from the low-level center. So it's not really like a true hurricane and kept primarily to the system center. And so what it needs to do is concentrate this wind closer to the system center, make it more symmetric as well. And then once that occurs and this vertical tilt is finalized, then we can see the system get into a phase of quicker to more rapid intensification. And by that point, we'll likely be into the day on Saturday, as models are still showing this process taking about a day to day and a half, or maybe even less than that, out to Saturday afternoon and Saturday evening when it may complete. And you can see it happen if we look at the HASS model. This is a depiction from a high-resolution hurricane model of how this may occur over the next several hours. This is out to this afternoon. And again, you can see this lopsided and asymmetric structure present in the model field. But as we go in time, we see the winds get more and more symmetric around the system center. And this helps to decrease that vertical tilt further and build that eye and eye wall structure. And eventually, as we head into tomorrow afternoon and tomorrow evening, we see now the system center has gotten much more symmetric and much more coherent. And by this point in the model, we likely have a more coherent eye wall, which is nearing completion by this point. And once that happens, the shear is low and the waters are plenty warm, so we'll likely see the system ensue in a phase of quick to rapid intensification. And we can see that happen here with the pressure number in the middle in that red starting to decrease at a very significant pace down below 950 millibars by 11 p.m. on Saturday on this model. Now, it may not exactly pan out like this, but this general evolution is what's expected from the hurricane models. We'll just have to see exactly how the timing works out on this. And talking about how strong the system could get, how strong of a phase of intensification could this be? That is one question, especially for Jamaica, as we could see the system make a direct landfall here. Now, they talked about how the shear has decreased. If we look at a vortex average sounding from the GFS, we can see that very clearly. The deep layer shear has decreased now onto the model forecast below 10 knots. Now, we do still have some moderate shear that is persisting and will likely persist throughout the forecast period here. You can see this max shear value of about 16 knots out of the north. That is coming from a ridge further north that's helping to steer the system towards the west. And if you look here at the 400 millibar layer around there, we've got this northerly flow coming in here. Now, an aspect of this flow is not a very thick shear layer. It's a rather shallow layer of vertical shear. It's not all too strong. 16 knots will likely put some pressure on the storm, but because it's shallow and not all too strong, it may not be able to inhibit the system fully. And so models like the HAFS that I just showed you still show the system intensifying even in the face of this shear. Now, the other thing that can hold it back is internal struggles that may occur as the system tries to finish off its eye and eye wall structure, especially as it intensifies for the first time. Typically, hurricanes have fairly unstable eyes at its initial peak. And so we may see, for that reason, eye wall replacement cycles occur. And in fact, we see some implication of that occurring in the model forecast here on the HAFS model. This is a simulated infrared imagery, or radar imagery instead. Sorry about that. But you can see the inner eye wall here getting surrounded by some stronger thunderstorms on the outside, implying that a secondary eye wall is trying to form on the model forecast. Now, these are very difficult to predict, and it may not happen like this, but as storms do intensify, they do typically go through an eye wall replacement cycle. And so that could stop it from achieving its maximum intensity here. We may not get to those very strong HAFS model runs a few days ago that were going sub 900 millibars. But a category 3, category 4, certainly in the cards here. And one thing to take note of is that even if we do go through a replacement cycle very quickly, the system is not going to be making landfall in Jamaica until about Tuesday. So it's got time after that replacement cycle occurs to re-intensify. And if indeed we see that happen on the forecast model, where the pressure just simply continues to fall through the process that we see with the internal evolution of the hurricane. And by this point, this is a strong category 4 to category 5 hurricane by this point. And really, the ceiling is pretty high here. It could absolutely get to category 5 intensity. Now, I do put some caution in saying that, don't fully focus on, is it going to be a Cat 4 or Cat 5? Regardless, it's not going to matter all too much, and the system will likely bring very significant to catastrophic impacts to Jamaica, regardless of the intensity that we see at peak. But, for specific wind impacts, we will have to watch exactly how strong this storm gets over the next few days. Now, talking about the track of this system, you can see that the system makes this westward bend And this is a pretty high confidence scenario now. We talked about a couple of days ago how the GFS was continuing to insist on the system coming into Hispaniola and coming north of the Caribbean. That door has now fully closed as there was an upper trough in the upper parts of the atmosphere that was doing that on the GFS model. But that trough today has now lifted out to the far north, and that door is now fully closed. And even the GFS is now caved to the other model guidance, showing this westward bend happening. Now, there is still a little bit of uncertainty in the fine details of this turn. Exactly when this westward turn occurs does have implications on the impacts and exactly how strong the system could get over the coming days. For example, the European and AI model suites, and I don't have the AI models pulled up, but the European is fairly similar, has this westward turn happening as it's still pretty far south in latitude relative to Jamaica and Haiti. This would be a scenario where we have the system, and you can sort of see it here on the HAFS model, where the hurricane force wind field is likely not impacting Haiti and Jamaica in the next 2 to 3 days on this forecast because it's staying pretty far south of those islands. But we have other models like the GFS and at times even the hurricane models. And in fact, I might be able to see it here. In fact, here, where you can see it's a little bit further north before it makes that westward turn, and it gets closer to Haiti and Jamaica. And not only does this impact the impacts to Haiti, this could increase the hurricane force wind threat in short term to the peninsula, but also this means that it can impact the intensity as it could just in those runs come into Jamaica, and that could impact how strong the system gets and prolong eyewall impacts to Jamaica there. And also there's exact details that are murky on when it makes a recurvature to the north. We know it's pretty high confidence that the system will at some point make a northeastward turn. The reason for that is because even though this bridge is here, it is rather weak. And we have this trough moving across the southern United States, and it's going to weaken this eastern part of the ridge. And so that's going to start to turn the system off to the northeast. And exactly when it makes that turn is a question mark. And you can see on this specific HAFS model run, it waits a little bit before making that turn. And we actually see the system come into southwestern Jamaica instead of eastern Jamaica, which some models have tried to show, even in the HAFS model in earlier projections. And so those fine details are still a little bit murky, and we still need to watch how those progress in real time over the next few days. But regardless, the key message is that this storm will likely be in very close proximity to Haiti and Jamaica for the next few days. And even if the core does not get close in the next 2 to 3 days to Haiti, we could see very heavy rainfall, which could lead to catastrophic flash flooding and landslides across that peninsula. And for Jamaica, with the landfall expected, the hurricane force wind field will come at some point. And even if it stays south, the rainfall will likely be very significant, even if it's staying further south. As you can see on this simulated radar imagery on the HAFS model, this is still very heavy rainfall falling across the high terrain in Jamaica. Now, what that does come in importance for the northeastward turn is impacts in Cuba and the Bahamas and Turks and Caicos. And there is still a wide range of uncertainty onto where exactly it goes when it makes that turn. The eastern envelope is like models like the GFS, which comes further north before making the westward turn initially. That will probably answer quite a few questions when we actually see this westward turn occur onto exactly when, we see this northeastward turn occur. But on the GFS scenario, it recurves such that the system actually gets very close to western parts of Haiti again, and we may see direct impacts there, but also the system's core may go over the Turks and Caicos in that forecast. We have the other suite like the European and AI models, which are more over here towards Jamaica, making the curve over central or southwestern Jamaica. And that may increase the impacts across much of eastern Cuba, but also in the southeastern Bahamas as it comes north out of the Caribbean. Now, something I should note for impacts in the Bahamas and Turks and Caicos and even Cuba and Haiti is that through eyewall replacement cycles, the system will likely gain size, but also through land interaction, the system will also likely gain some size. So you'll see the wind field here does gain significant size as we go in time, and the hurricane force wind field grows exponentially as we get towards Cuba and the Bahamas and Turks and Caicos. So it may not ultimately matter exactly where the system center goes. We may still see very significant storm surge, heavy rainfall, and winds across eastern Cuba, Turks and Caicos, Bahamas, and even northwestern Haiti as the system makes this recurvature to the north. But of course, we'll watch the exact details for the next few days. For now, this is the current forecast coming from the Hurricane Center, which gives you the best envelope of where the system's center could go. And you can see the intensification occur over this weekend, intensifying into a major hurricane, again getting very strong, but potentially category 4 or category 5 in this range, and then making that gradual bend towards the northeast, coming into Jamaica sometime on Tuesday. And the timing may also be worked out for the next few days, but general expectation is early next week, Monday or Tuesday, the hurricane is coming into Jamaica by that point, likely as a major hurricane. And we have a hurricane watch in place right now for southern Haiti and Jamaica, with a tropical storm watch in effect, or tropical storm warning rather, in effect for both areas. We'll likely see, I'd imagine, a hurricane warning issue for Jamaica sometime tonight or early tomorrow. And from there on throughout this weekend, we'll likely see watches and warnings expanded through Cuba, the Bahamas, and Turks and Caicos as the system's timing from when it gets up here gets closer to reality. And finally, what I'll show you is the rainfall forecast from the Weather Prediction Center. You can see again, like I was talking about, catastrophic rainfall being potential here for Hispaniola and Jamaica. You can see across southern Hispaniola as a whole, we can see a widespread zone of 100 to 300 millimeters, especially in the southern peninsula of Haiti. We could see very heavy rainfall. In fact, the Hurricane Center specifically states that we could see some localized totals in the high terrain exceeding 750 millimeters, getting close to a meter of rainfall in some spots. And the same story is true across Jamaica. You can see the very, very heavy rainfall that falls across the island in this forecast just throughout day 4, and that could extend even more in the 5-day forecast as well, and that will likely lead to, again, catastrophic flash flooding and landslides there. And the forecast only goes out to day 4, but very significant rainfall also could be possible for eastern Cuba, the Turks and Caicos, and the Bahamas as the system makes that recurvature off to the north. So a long duration event ahead of us throughout this weekend into next week, and I'll have more videos on this as we go in time as the system intensifies throughout the next several days. I'll leave links to local weather offices that I can find at the top of the description and the Hurricane Center website there as well. But stay safe as the storm progresses closer to these islands. That's all for now. Thanks for watching.